I'm going to show you three more examples today with solving equations with variables on both sides, because there's some unexpected things that can happen and you need to be able to deal with those. So this first one, we're going to start out with, on this side, we have to distribute this 3 first. So we're going to do the distributive property there. And so we have 3x minus 1 equals 3x plus, that's 3 times 3 is 3x, 3 times 3 is 9. Okay, so now I've got to get all the variables to one side. Well, as I do that, if you see what happens here, when I subtract 3x from here, and I subtract 3x from here, the variables are gone. And the only thing I have left is 0 minus 1, which is negative 1, and 0 plus 9, which is 9. And they are not equal. So what that means is, it's not a balanced equation, and that means that there's nothing that I could put in for x that would make this side equal to this side. So, and if we look at that, and I just, some people say, well, how come negative 1 can't be a solution? Well, let's try it. So if I check this and try negative 1, does that equal 3 times negative 1 plus 3? Well, let's see. 3 times negative 1 is negative 3. Negative 3 minus 1, that's like plus negative 1, so that's negative 4. On this side, negative 1 plus 3 is 2. 2 times 3 is 6. Okay, no, it won't work. 9 won't work. No number will work because these two are not equal. This is to say that they're equal, that would be a false statement. Okay, it is false that negative 1 is equal to 9. So that means there is no solution. Doesn't matter what number you pick. It's not balanced and the x's drop out. Okay, so here's another example. And you can check any number you want. It won't work. Okay, so let's go to the next example. So this example, example 2, now this looks a little different, but you have this negative outside the parenthesis. Well, this means the opposite of everything in here. Or, if there's no number in front, we could say there's a negative 1 if you'd rather do that. And if I put a 1 coefficient out there, and put a plus negative 1 coefficient here, that negative out there means I'm taking the opposite. Well, it'll do the same thing if I distribute a negative 1. So if you'd rather see a negative 1 being distributed in there, both sides, that's fine too. So let's go ahead and distribute that negative 1, or take the opposite of both of these. So negative 1 times 2x is negative 2x, plus negative 1 times 2 is negative 2. So we've got the opposite of both of those. Now we have that minus 1 there. And then on this side we have negative, and I'm just going to call that negative 1x, because there's only one of them there. Plus, now I'm going to do negative 1 times x, which is another negative 1x, plus negative 1 times 3, which is negative 3. So I just now have the opposite of both of those two things in parentheses. So now I'm going to combine like terms on both sides. Well, there's no other x term, so I'm going to add these two, because I can say that's plus negative 1. So that's negative 2x plus, and these two added together, negative 2 plus negative 1 is negative 3. On the other side of the equation, I can combine these two negative 1x's and get negative 2x plus negative 3. Now, I don't know if you've seen, but kind of the same thing happens as the last example. When I go to get rid of this, that one's going to drop out too, because they're exactly the same. You have the exact same thing on both sides of the equation. So when I add 2x here, and I add 2x here, the x's drop out. And at this time, though, I'm left with negative 3 on the left and negative 3 on the right. So they are equal. That is a true statement. Okay? So if you back up to here, if you've got the same thing on both sides of the equation, whatever you put in for x here and multiply it by -2 and add -3, well, if you put that same number over here and multiply it by -2 and add -3, you're going to get the same answer. So it doesn't matter what you put in for x. You could put in 1,000,000, multiply it by -2, add -3, put in 1,000,000 over here, you're going to get the same answer. So any number put in there will work. So the answer is all real numbers. And there's a symbol that we use for that. It's a double-lined R, capital R, and that means all real numbers. So you can either say it, I like the symbol, it's much easier. All right, so when you simplify an equation and the x's drop out, the variables, whatever the variables are, drop out, and you end up with a true statement, then that means that was the same thing on both sides, so any number will work. So the answer is all real numbers. If you end up with a false statement when the variables drop out, then that means there's no solution, because it doesn't matter what you put in for this x or this x. When you multiply that x by 3 and subtract 1, you're going to get one answer. And when you take that same number and multiply it by 3 and add 9, you're going to get a different answer. So it's never going to work. So we say no solution. Alrighty. And I said I was going to do 3 examples, but I think I'm finished. Okay, now you also saw the other day we did some examples where you can get a solution and you have to go back and plug it in and check it. And so that will be the 2 examples I'll show you for today. And we'll see you tomorrow. And how about you just have a big smile on your face when I come around and check your equation. You just look at me with a big smile, and I will know that you watched this video. Have a great day.